two sessions I've got on containers run effectively back-to-back, and we'll cover the life cycle in this one and the more DevOpsy stuff in the next one. There's a lot of stuff to get through, and if you've got questions, we'll take them as we go. We can take stuff offline afterwards if you have got more questions. First thing to remember, this is all experimental technology. It's a community preview. We're currently on 4. As was said yesterday, there is TP5 coming. In the summit, North American Summit a couple of weeks ago, they said it would be dropping about the end of April. So whether that works or not is another matter, but certainly within the next month or so, we should see the next TP4 server 2016, and some of this will change. The one thing that is definitely changing is the commandlets that I'm going to be using today will be working over the Docker API rather than the whatever they're doing now. But that shouldn't change what they actually do, it just changes the underlying stuff. I hope. Okay, so what are containers? Installing the feature, creating, installing, managing. And if we get time, we'll look at containers on Nano Server, which gets really funny because then you've got experimental technology on top of experimental technology. It works, usually. When we get into the DevOps stuff, we'll look at the DevOps principles, containers as infrastructure as code. I don't know why I put creating containers with DSC, because I'm not doing that. And then moving containers into test and production. So that the container becomes your delivery object. Just to be interesting, I thought I'd do everything on Server Core and Nano. Anybody tell me which film is misquoted? Pardon? No? It's the Treasure of Sierra Madre with Humphrey Bogart.
I was going to say that.
Too late. No prizes.
You received the prize already.
Okay, so containers are not equal to Docker. Docker is the API for managing containers. Usually you see a lot of people talking about Docker containers and Docker this and Docker that. No, Docker's just what you use to manage them. They're new to Server 2016, or at least on the Windows platform. They've been around in Linux for quite a while. It's a very lightweight virtualization object. It's not a virtual machine. It just thinks it's a virtual machine. It's mobile. You can easily move it between servers and between environments. It's an application delivery mechanism more than anything else. The applications see an operating system, even though there isn't a full one there. And probably the best concept, has anybody worked with AppV or application virtualization? So you create a bubble that the application sits in, and it thinks it's running on a full machine and it's got access to everything, but it's only got access to what you allow it through the bubble. A container is a similar concept. So the application is sat in what it thinks is a full machine, and it's actually just a container, an object for the application to sit in. They share the host operating system. You can run containers either inside another Windows machine or directly on top of Hyper-V. For this demos, I'll be running them all in VMs because you need Server 2016 Hyper-V to run them on directly on Hyper-V. And you can, for TP4, you can manage through PowerShell or through Docker. If you create a container with PowerShell, Docker can't see it, and vice versa. That is a TP4 restriction. As from what I'm hearing, that will go away with TP5. The difference between Windows containers and Hyper-V containers, It's just one of approach. The Hyper-V containers are effectively more isolated, so that the applications are untrusted, they don't trust other applications, and things like the memory are signed directly and they've got their own kernel. The Windows containers are much more of a sharing, caring environment. On TP4, and I'm not sure that this will change, depending on your host operating system, you are limited to what you can run as a container. So if you look at the full UI, the 2016 full UI, the Jeffrey SAD server, you can run a server core OS image for your containers. If you're running them as Windows servers, if you're running it as a Hyper-V container, you can run Nano. Nano is the only one that you can currently run as a Hyper-V container, and if you're running Nano server, you can only run Nano Windows containers. How much of that is going to change as we get to TP5? It's unsure, but I think because of the way the containers react with the underlying operating system, you're still going to keep these restrictions. This is one of the most important points. If you patch the host that your container lives on, you must patch the container OS image.
What is practice for the patching? Which should you patch first?
Which should you patch first? That's a very, very good question. I think you would have to patch the host first for it to be. So I suspect the process would be something like stop all your containers, patch the host, patch the container OS image, and then bring your containers back up. I haven't tried it because we haven't had any patches for 2016, so it's a bit difficult. But it's something that is going to be an issue going forward, which is why running your containers on Nano server may be advantageous, because your patching level is going to go down an awful lot, and even server core is a good bit less. Yep.
I was assuming that container was just directly targeting the host processes and then share that process.
So you're assuming that the container targeted the host processes and shared those processes.
Yeah, follow that somewhere.
No,
So if you patch the host, it will target the right process.
no, because this diagram actually explains why. So if you start at the bottom in this column, you've got a container OS image. You've got an application image, which can be the website, it can be MySQL, it can be whatever you want to run in your container. And you've got a sandbox, which is where the changes and whatnot happening. Those two come together to create the container. So you've got this container OS image, which is created from the WIM file for the base OS. And that is what the container is actually using. So it's shared across containers, but it has to be there, and it's separate from the OS of the host. You with me? Yeah. So they don't actually directly share the host processes. Networking for containers gets quite interesting. You've got two options. You can run it in transparent mode at the bottom. So that's running off an external VM switch. You get the IP address for the containers from DHCP, and you need to max boost the container host. That's fine if you're running on Hyper-V containers, because all of your things are going to be running on the directly on the host. And in one question I've had before is how many containers can you get on a particular host. It's going to depend on the resources you've got available on that host. To give you an idea, if you're just packing nano servers onto a 64 gig machine, there's one of the PowerShell MVPs managed to spin up 384, I think it was, nano servers on a machine like that. Containers are even smaller, so in theory you should be able to spin up even more of them. So it's basically what your hardware resources are that's going to control what you've got. The other networking option is to use NAT, network address translation. Does everybody understand network address translation? No. Oh. Okay. Inside your organization, how many of you use one of the private IP address ranges, 10.10 or 10.x, 192. Whatever it is, 172. Something? Yeah? Right. How many of you have internet connectivity out of that organization? Right. At some stage, somewhere in your organization, there is a machine that is taking your private IP address and matching it to a particular port on your external facing connectivity so that you can get to the internet. And that's what network address translation is. It's basically taking an internal address and mapping it to a port on a box with an external IP address. The advantage of using NAT is that you've got many containers on a single external address, and you can work with multiple containers with applications with the same port requirements. If you've got a lot of Windows machines hosting containers, you're going to rapidly run out of IP addresses if you're using a lot of these. So natting is a way of getting around that. Whether you go natting or transparent is going to depend on your environment and what you're trying to do. For the demo here, I'm using the NAT approach, A, because it's the more complicated one and it makes better demo to get that explained up front, and 2, because my Hyper-V host is still 2012 R2 and it doesn't understand the new VM switches. The other concept with containers is shared folders. These are folders on the host that the container can also see. You put something in the folder on the host and the container can get access to it, and vice versa. It's just a method of moving data in and out of containers. Good for software delivery if you can package it up so that it goes through that way. So the process for working with containers, add the containers feature to your virtual machine or to Hyper-V, add the container OS image. There's 2 ways you can do that. The first one is to pull it down from the PowerShell gallery by installing the package provider for containers and then install container image. Remember that the container image must match your host. Or you can actually download the WIM file using save container image and then use install container OS image. I'm not going to demo actually pulling down the image because you sat here watching me download 3.5 gigs of data is probably not the best use of your time. You need to configure the VM switch for the containers, so you've got your networking, configure NAT if you need it, and then you're away creating the container, add a network adapter either afterwards or during the creation process, connect it up to the network adapter, and create the shared folder if you need it, create any NAT mappings, take your firewall down or configure it. I've taken it down because I can't figure out port mapping. It just does my head in. And then configure your container with your application. All done. Right.
Can I ask a question?
Yeah.
With regards to the shared folder, is there anything like NTFS, or do you need to be in the same domain, or is it a security risk at all?
Okay, with regard to the shared folders, is there a security risk? Do you need to be in the same domain? Is it NTFS? If you're running your containers in a virtual machine, the virtual disk that you've got your container shared folder on, it will just pick up whatever formatting that is. By default in Windows, it's NTFS. The container will see it as NTFS and work accordingly. Containers, at the moment, you can't actually put them into the domain as an object. They are a application delivery bubble, not a virtual machine. So the container object itself doesn't go into the domain.
So whatever is in that container doesn't matter to be part of the domain that hosts it.
Yeah.
Okay.
Okay, I'm now going to hope that the demo works. So I've got a Windows 2016 server core machine. I put a static IP address on it. It's domain joined, and I've taken the Windows firewall down. I've done a couple of the early steps just to move the demo along. So to install the Windows feature, it's exactly as you would expect. Install Windows feature containers. You do need to restart the machine, and you need to create a VM switch. The switch type of NAT is a new one within 2016 Hyper-V. You give it the subnet that you want to use. You create the VM switch. You create the VM switch. That is a problematic activity on TP4. It fails, and then you run it again, and it works. I'm hoping that that's a TP4 issue rather than an ongoing issue. But if you decide to try any of this before TP5 comes out, just be aware that the switch creation can fail. You create the network address translation setup, and you then need to install a package provider, and that will pull that provider down from the PowerShell gallery. You can then find your container images exactly as you can use find module or find DSC resource, and then you can pull down the install container image. If you want to install an image that you've already saved, then it's just install container OS image, and you give it the path to the WIM file. Okay, so I've done all of that just to move the demo around, because downloading over the network here would probably take until the end of the day. Installing the OS image takes about 10 minutes. So I've just done that to get it out of the way and get us to the point where we can actually run. Let's do it this way, and then you should be able to see. So once you've got your container OS image installed, you will see something like this, and it will tell you that it's server core. It'll give you the version. It will confirm that it's an OS image. Keep that little bit in your mind. It'll become useful later on. And it's got a full name, including the version. Versioning will become apparent, while you need to be careful with that later on. So creating a container is very straightforward. As with anything in PowerShell, if you want to create something, it's new, you give it a name, and you tell it the container image that you want to use. And that's our container created. You can see that it recognizes the parent image that you're using. It's created in an off state. And you've got the creation date. Notice at the moment there aren't any network adapters. You can create a network adapter as you create the container by telling it which switch to use, but I wanted to go through the whole life cycle. So you can, as you'd expect, you've got a get container which returns more or less the same information. If you look at the files that are in use, so you've got the Windows images folder and you've got the Hyper-V containers folder. Those are changeable if you wish. If you do move them, make sure that you put them somewhere where anybody working on that machine can get to. TP3 had the interesting idea of putting them into your profile area, which was great for you, but nobody else could get to them. They woke up and realized that that one wasn't going to work. So next step is to add a network adapter, and it's very simple. You just tell it to add a network adapter to the particular container, and then you need to connect it up to the switch, and then you need to add a static mapping. So I know that because the container is effectively picking up a IP address off the NAT switch in a sort of DHCP type approach, I know that the first address it's going to pick up is 172.16.0.2, which means that's my first container. It's going to map the internal port 80 to the external port 80 because it's going to be a web server type container. Everybody happy with that bit of code and what it's doing? So it's adding an adapter, it's connecting the adapter to the switch, and it's setting the mapping from the internal adapter to the external adapter. Right. And you can view the static mapping. These get netnat commandlets are all in Windows 8 and above. It's all part of the networking stuff that came out then. Right, so we can start the container, and then we'll look at the IP config and the processes, and then stop the container. Hopefully this will come back telling us that it's... So there's our container. There's our IP address, and there's the processes running in the container. I'll just switch this to that mode so we can look at the processes. If you look at the processes, it's not a full set. That's it. You'd expect more than that which is why I was saying it's not a full server. It's just enough for the application to think that it's a server. Just to confirm this, we'll look at the same data on the host. You see there's an awful lot more processes in there, and we've got different IP address. Okay, so I'm now going to install, let's go back to this format so you can actually see all of the code. I'm now going to install IIS in my container. So I'm going to start it back up again, I'm invoking a command over the remoting session, and then I'm using invoke command to talk to the container within the remoting session. No, that's what I thought when I first started doing this. The comment was double hop. Does everybody understand the double hop issue? Yeah? Right. This actually, when you're working with containers, double hop goes away. So you can remote onto your host, and then you can remote onto your box. In fact, let me show you. This is neat. Yeah, actually, this is it. So this is a remote. This should be a remote session into my. Yeah. How cool's that?
Okay.
Yeah? You can't do that with standard remoting. So you can actually create a remoting session into your host and then create a second session from that into your containers. It only works with containers. It's not a removal of the double hop issue. As far as I'm aware, it's container. It's a container independent. I've not tried it with Hyper-V containers because I've not got them set up. But logically, I can't see any reason why it wouldn't work that way. So. Oh, don't you dare. Right. I'm just going to stop the container so that it gets back to where I need it for the other demo. Otherwise, I would be very confused. So while that's just running, so we've installed the containers feature. We've pulled down the container image or got it onto that box one way or another. We've got that installed, and we've then created a container. We've set the networking up, and we've got it connected, and we're now installing IIS. Is there any questions at that stage?
Actually, yes. One of the things that you said is only the processes are running that are needed for a particular application. Right?
Yeah.
And then you manage to install the application after that.
Yeah.
How does it know in advance what kind of processes it needs?
Well, when you install in IIS, you're going to get the IIS bit will get picked up. Okay. But remember, you're installing IIS into the container, not onto the host. So, yeah. So it's a bit like virtualization takes stuff from the host and thinks it belongs to the virtual machine. It's the same with the containers. They take stuff from the host and actually think it's part of the container.
Resource on demand.
Pardon?
Resource on demand.
Resource on demand is probably a very good way of describing it.
Okay, okay, thanks.
While that's running, as a little aside, remember Jeffrey was talking about Nano Server yesterday. And what might be fun is, while that's just running through, have you played with Nano Server at all? Yeah? No? How many people haven't? Okay, this is worth doing then. How many of you created virtual machines from scratch using Windows Media? Yeah? How long does it take? Too long. Good answer. Who said too long? Have a prize. I like that comment. I'll just make sure that Tobias scrubs it off the recording so that... Right. On the ISO for Server 2016, you'll find a folder called Nano. You can copy some of that stuff onto your local disk, and then once you've done that, you run this new Nano Server image. Actually, let me show you what I've got. So you get this Windows Convert image script. You get this image generator module. That's the size of a new Nano Server. That's the Nano Server WIM. That's the size of a container. And if you look at those are the install software for the features that you can put on Nano Server. Remember Jeffrey said that they lived outside Nano Server? They come as cabs that you've got to install separately. To create a new Nano Server image, or the hard disk, so it's going to take that WIM file and it's going to create a virtual hard disk. If you look, while it's running, if you look at the code, I'm reusing the domain name, or the domain node name. Language is restricted to US English in this release. You need to give it where you want the virtual disk to be created, the size of it. I'm adding in the guest drivers, reverse forwarders, which is for applications, the Hyper-V feature, and the containers feature. Give it a name, give it the domain name, the network card, give it an IP address, the subnet mask, and enable the remote management port that Jeffrey showed yesterday. Okay, so that is created the base virtual disk. It's now adding in the packages that we asked for. Come on. But what you will get out of this is a virtual disk that is complete, ready to boot, domain joined, with an IP address set, ready to attach to a virtual machine and go, that's done. That is a Nano Server created from scratch, ready to go, ready for you to install your applications in.
So,
Quick?
All those caps, did all those caps get installed right away?
No, just the only ones that were installed were the compute and the containers. There are other switches for the other cabs, or you can do a online install. You copy the cab into the Nano Server and then use DISM to use DISM to install it. That's creating a nano server from scratch. A little bit quicker than even setting up server core. And you saw yesterday how quickly the thing starts and whatnot. They really are very lightweight and very, very quick. Right, that has worked for us. So let's actually, so we've installed IIS in our container. So what we should be able to do is, if I can remember the correct IP address, that's running against the, that's IIS running in the container. So you've got your container hosting IIS, been natted out to the external address, and that is what you get. Okay.
Excuse me, one question. If you have a second container with another IIS, then the port 80 is blocked, or is there...
I'm just going to actually do that next. So the question was, if you've got another container on the same box with port that also wants to use port 80, your port 80 on your external card is blocked. What do you do about it? Okay. I'm just going to go through that and show you. So, excuse me. Remember that we had the bare bones container OS image that we used, and we used that to create a container, and then we installed IIS into it. Now, how many of you like doing the same task over and over again? Yeah? Excellent. The door's there. Please close it on the way out. So, yeah. So the idea with containers is that once you've got your container configured, you can use this new container image to create a new image from that container, which you can then use to create other containers. It gets a little bit, A and B and C. It's a bit like creating a virtual machine template. It's exactly the same concept. So I'm going to set this going. And we shouldn't take too long, he says. This machine's getting a little old and sometimes decides to complain. Unfortunately, you don't get any progress bars on this one. But what it's doing is taking the container and taking the stuff out of it that it needs to get that image. Any questions on containers while we're going through?
So it's doing two steps. It's doing something like a clone and doing sysprep and then domain joining again with a new name?
Yeah, containers aren't domain joined.
Okay.
It's okay. So actually, let's try drawing. I'm not very good at drawing, but okay. So we had the original OS image that we installed. We created a container. We're taking that to create a new image. And then we can take that to create a container. And the idea is that because we've configured this with IIS and everything else that we need, including our any sort of website application type stuff, when you create an image and then create a container from it, you've got all that set up. So that it's a quick way then of cloning more containers that are configured in exactly the same way.
But they're dealing with references, not with copy, a physical copy.
It's not a reference, because when you create a new image, it exists separate from the container. So the new image and the original container are two separate objects. You could in theory, you could get rid of that container, but you'd still have the image. Once you've got that image, which is effectively your template for new containers, you can then spawn off as many containers as you want from that.
Question.
Yeah.
When you install then a website, so you finish your application, before you make the new image, will it be part of the new image? I think so. But
Yeah, if you starting a development, if you're deploying, you can create a new container, deploy your application into the container. We're jumping into the second session, but while the question came up, so you can deploy your application into a container. You can then create a new image from that container. You can export that image, copy that exported file, and it's an APPX file, off to another host, install that or import it. You've then got that image on that host, and you can create containers that contain your application. So it's like you've all heard of the sort of Xcopy type deployment. Yeah, it's a way of doing that, but you get to take the infrastructure with you as well. Okay, so that's run. So is everybody clear on what we've done with created the container and then created the new image? And if we look at the just kick that off, then I'll explain what I'm doing. So I'm creating a new container called test2 using the new image that we've just created. I'm connecting it directly to the switch, so that adds the network adapter. I'm getting the containers and I'm starting them. One thing with if you've got a lot of containers that you're starting one after the other, be careful of the order that you start them in, because the switch just allocates the IP addresses in order as the containers start up. So if you're expecting particular IP addresses to be allocated for your net mapping, just be careful on how you start them up. And that's our new container created. Let's anything in there that it's all stuff that you've seen.
What are the MAC addresses generated? Is that like a random?
Yeah, it just magic. It's dynamic like with virtual machines. So we now got two containers running. And you can see that the TST container, which is the first one that I made, is running. Can you see that text at the back? Yeah, okay. That's created off the original server core image. The TST2 is created off the new image that we made. And if you look at the images, so our original one came from Microsoft. It's the 10.0.10586 version, and it's an OS image. Remember I mentioned that when we looked at that at the beginning? This is the one that we just created, which is a name that we gave it. Publisher is just my company. It could be anything. It just needs to be a name. It's a 1.0 version, and it's not an OS image. Using the new image that we created, you still need that original OS image around.
Does it need to be running?
Beg pardon?
Does it need to be running?
It needs to be installed. Actually, I'm just going to double check something. Right, okay, we're in business. I just wanted to make sure that I'd actually run that and not run it again. I did that once running through this and it confused me no end. Okay, so remember I mentioned shared folders? I'm just going to create the shared folders. You need to have the containers stopped to do that, and basically you just tell it to add a container shared folder. I'm going to start the containers up. And what I'm going to do is, because I've got two containers, both running IIS, they're both going to run that same page. So just to prove that it's not all smoke and mirrors, I'm actually going to change that default page on both machines, on both containers. And what that's doing is I'm just going into the container, stopping IIS, changing the PNG file, and restarting IIS. So, assuming that has all worked, if we go back to our 55, that's now the test container. And you asked about if you're running IIS on a second machine. If you remember from the net natting, I used port 82 externally, and that's the other one. So we've got two containers running, both with IIS installed and both with our image installed. And that is now 9:50, and time for a break. If that's the end of this session, if you've got any questions, I'm quite happy to. Yeah?
What is exactly the difference between app-v and container?
What is the difference between app-v and containers? Okay, how long have you got? Okay.
Just
No.
basic overview.
All right.
App-v is going to be installed natively in Windows, so but I thought,
Okay.
is it going to overlap?
No, app-v is a method of delivering applications. So it's application virtualization, effectively. Containers is a way of delivering, and its primary use, I think, is on client machines. So you package Word up into app-v, and you drop the bubble down onto the client machine. They think they've got Word installed, they're quite happily using Word, but they haven't. It's just the app-v bubble. Containers, even though they do run on Windows 10, that's much more for a development idea, they are a way of delivering applications that are going to be hosted on a server. And so things like websites, if you look on the containers information on MSDN or TechNet, whichever it is, there's a list of applications that they've tested. So things like MySQL run in there, Apache they've tested, obviously IIS. If you're getting to the point of thinking of squeezing SQL Server in, then you probably don't want to be using containers. Any of the really big enterprise things like that, containers are the wrong thing. But it's the small applications that you want to generate a lot of copies of, or a lot of very similar instances of, that you also need to be quite mobile and quite quick going through your test and into production. I'll show you how you can do all of that in the next session. Conceptually, app-v and containers are very similar. In how you use them and why you use them is where the differences lie. Does Does that answer you? Okay. Right. So
Does system allow you to destroy parent partition?
But-
Now you have a base image,
yeah,
and you get child items from that.
yeah.
Does the system allow you to just destroy the parent image?
So can you destroy the parent image and keep everything working? Unlikely, because yeah, it basically it's a layering thing, and you need that that underlying image. The image that we created assumes that its parent image is there, and if it's not, it's going to complain, because it's the image that we created is basically the differences between the container and the original core.
So if you say,
that will just try to do such stuff.
Yeah, it would just
We need to make it foolproof.
yeah.
so if you're saying someone is portable, you need to take the father and all the generations.
Well, no, because it depends how many generations you go down, and it's like a lot of these generational things. There is a sensible limit at which point you say, well, okay, I will actually reset and come back. And that's going to be part of your process as to where you draw the line between creating an image from an image from an image from an image from the original. Where in that process do you get to the point where it becomes too unwieldy to manage all of these images? And you say, well, okay, I will stop, reset, and that becomes my new starting point.
So, setting resource limitations on a container, is that possible?
Yes, you can control the memory and the CPU that it uses. I haven't done that in here because I've only got a couple of containers running, but you can control the memory, you can control the amount of CPU that it has access to.
You said that AppV is more client thing,
Yeah.
and the containers are more server thing.
That was the AppV for clients was a very general statement that
Are the containers more designed to push around from one server to another?
yes and no, in that it's an easy mechanism to move applications from one server to another. And that is part of the reason for having containers. AppV, yes, you can also move applications very easily from machine to machine. And as I said, conceptually they're the same, but in practice there are obviously a lot of differences between them.
On top of that question, like we know when you use VMware and you want to bring a container from a failing server to another server,
Yeah.
is that part of the strategy of Microsoft to do that on the fly? Or
So-
the web server in the air?
So if I understand your question correctly, can containers fail over from one machine to another? In TP4, not as far as I'm aware. I was having a discussion yesterday that suggests that in TP5 that will be possible. I haven't, until we see exactly what's in TP5, I can't really answer that question. I would assume that eventually it will be there, because it'd be rather stupid if it wasn't.
Since it's so fast to create one, what would you say, you move it or just throw it away and create a new one?
It depends what you're wanting to do. If you've got the image of that container on the new machine, it may actually be just as quick to bring up a new one. And if it's something like a website where you've got many instances in a web farm, it's probably just as quick to bring up a new one. If it's a more unique type application, then you would probably want it to fail over. Sorry, there's a question.
What is about patching and Windows updates?
What?
You do the Windows updates on the base image? Or
Yeah, you do so the question is around the patching and the statement that I made that you need to keep the host and the container image in sync. It's the host OS and that. We got it here? No. Let me
so can you change the base image and the application container it is still running? Or
Unknown. I would. So the one that you are patching is this one, the OS image. This is just a delta between your container and the original image. And if you need to patch, you just patch in the bottom one and everything else will bubble up. Any more questions?
Does containers support data deduplication or
So support what type of application?
data deduplication?
Sorry?
Data deduplication.
Data deduplication.
Is there really a need?
I'm not sure that there is a need, and I'm not sure that if it does. I suspect at the moment it doesn't. Okay, if you want to grab a coffee, now would be a very good time to do one. If we can be back in a few minutes. Thank you.